Hello everyone, I wish everything is fine. Now we are going to do practical one, building a multiple sequence alignment. This is very simple practical. This practical one for lecture 1. And this is a part of Introduction to Bioinformatics online course IBT 2016. For the people who don't know this is online course organized by H3A Bionet, and it has many modules. This is one of the modules, which is multiple sequence alignment. We will go through lectures and through many practicals to practice how to build a multiple sequence alignment and how to extract information from it. So in this practical, simply we'll go to XPASI and we'll extract heat shock factor 1, which is a protein, and we'll see the sequence of that protein, and simply we'll get this protein sequences from UniProt KB, UniProt knowledge base, and then we will check heat shock factor 1 from different organisms. In this practical, for example, we will select human, rat, mouse, Arabidopsis, chicken, pig, and we will take the heat shock factor 1 from these different organisms and try to make a multiple sequence alignment between heat shock factor 1 from these different organisms, and see which one closer to the others and what are the domain that they all contain and what is the difference between them. After we select these, of course we will download them in FASTA format and we'll keep them, and also we'll do alignment using cluster omega. And for just out of curiosity, we can simply build build a phylogenetic tree based on the heat shock factor 1 between these different organisms, and see how close the gene in different organisms from the evolutionary point of view. And also one extra thing that we learn in this practical, that simply we can also add, we learn how to add one more sequence to the aligned sequences. So if we want and see how it's related or not related to that. So simply we will go here as for XPASI, we'll go to this link www.xpasi.org/proteomics, and simply we will just write down heat shock factor in the search box and click search. When we write heat shock factor HSF1, simply we get many hits. We will choose UniProt KB, UniProt knowledge base, which will give us more than 1,781 hit at least. And then after that we just after clicking that, we'll get the sequences in that kind of table. We will check the organisms that we just said. So we'll select human, rat, mouse, Arabidopsis, and chicken pig, 6 different organisms, and simply check the box in the left hand side, and then we download in FASTA format. We will get something like that. Simply we'll copy and save it in Notepad, in its text file, and save in FASTA format this text file. After, we will just keep it in our folder, so we can come back to it later. At the same time, we will keep the same browser open, so we can return back and just press align. So we now before pressing align, we just saved our sequence using download button, and now we return back to the same page and we'll press align. This will lead us to alignment between selected sequences. As we can see now, this is the align. We will get the result as alignment sequence between all the selected sequences. Simply we can save this alignment also in FASTA format and keep it in our folder also. So now we have two folders, now we have two files. One have our sequences in FASTA format, which we'll use it later, and the other one is have the alignment. This alignment file, and both of them are in FASTA format, the alignment file and the sequence file. If we go down to the end of the page, we will see that the program just also made the phylogenetic tree, and simply from that tree we can see which sequence are closer evolutionary from the evolutionary point of view to the other sequence. So this tree we can see here that the mouse and rat are more closer than the human, and then the pig, and then the chicken, and the Arabidopsis is the one far away. So simply this is a simple tree that have been built based on the sequences which we just showed and which we just used in this practical. So another one more thing that we can add, one more sequence here to our alignment. So we can just simply to practice this good thing, that we simply can extract another unrelated sequence and put it here in that box, and simply we can just write down, press simply add sequences and align. When we add this unrelated sequence, simply we can see that unrelated sequence, for example insulin gene, whatever, insulin protein, any unrelated sequences, we can see from the phylogenetic tree that this unrelated sequence will not be suitable to align with the heat shock factor 1, and this will be out group, and simply this branch will branch far away from heat shock factor and will not have the same nodes to be related to the other organism. This is not, of course, building a phylogenetic tree is not our main domain here, not our topic here today, but that will be tackled in different module in the future. So we'll keep this just building the multiple sequence alignment, and keep the files, the FASTA format file of your alignment and of your sequence in your desktops, so we can use it in next practical. So I hope this was simple and easy, and we will tackle different practical in the next lectures. So thank you for listening, and we will hope to see you again and listen to other lectures again, and keep it simple. Thank you.